Hello everyone, my name is Conor McCabe and I'm a first-year PhD student at the University of California, Davis, and today I'll be talking about my master's work that was completed at Purdue University as of December 2020 on gestational muscle and adipose tissue thickness impact the use of these reserves in periparturient cattle. And looking at the transition period of interest, we know from previous work that cows must mobilize both muscle and adipose reserves in early lactation to bridge the nutrient gaps present between the amount of nutrients required for milk production versus the amount of nutrients supplied through the diet. Further previous work has shown cows with greater adipose reserves tend to mobilize more tissue, which is observed through vast changes in subcutaneous fat, as well as increased fatty acids in plasma, as well as increased milk fat output for those cows that are mobilizing more tissue. Mobilizing more adipose tissue can also as a precursor to the development of metabolic disorders, which each have their own negative impact on animal welfare, subsequently animal production, and this therefore negatively impacts on-farm profitability. We know, and then we subsequently know that when milk production nutrient requirements are lower in late lactation, these reserves of both adipose and muscle, we tend to think are reaccumulated in late lactation so that animals have a similar body condition score in late lactation as compared to the time of calving. There are a couple of ways that we can look at monitoring the body reserves that cows have, with the first one being ultrasound, which looks at muscle and fat thickness at specific parts of the body. And this correlates very well with total body protein and adipose respectively. As well as looking in the plasma, we're looking at creatinine, which is a marker of muscle mass, as well as the metabolite of 3-methylhistidine, which is a product from muscle breakdown, and therefore animals that have greater muscle reserves will have greater creatinine concentrations, and those animals with increased muscle mobilization will have elevated 3-methylhistidine concentrations. So putting those two slides together, we hypothesized that dairy cattle with greater longissimus dorsi thickness, or LDT, during the dry period will mobilize more muscle, have greater 3-methylhistidine concentrations, and have elevated milk protein concentrations in early lactation based on previous work in adipose mobilization. The way we wanted to evaluate this is to evaluate differences in tissue mobilization, metabolites, and milk production between cows with high versus low LDT in late gestation through early lactation. We initially performed this by looking at ultrasound images collected at the right side of the cow at the 12th intercostal space at 3 time points during late gestation at 35, 21, and 7 days before expected calving, or BEC, as well as at 0, 10, 30, and 60 days in milk. These images were then quantified using the computer software program of ImageJ for LDT, which in this figure here is 4.33 centimeters, and subsequently looking at back fat thickness was subsequently 4.2 millimeters for this image at right. On top of ultrasounds, plasma samples were collected at 35 and 21 days BEC, as well as at 2, 7, 14, and 21 days in milk. This study was part of 2 experiments focused on circadian timing disruptions in transition cows, with the first experiment performed in 2018, whereby we had 25 animals enrolled, and the following study happened the subsequent year in 2019 with 16 animals. These animal numbers were then pooled to have a total number of 41 cows. And then based on LDT at study enrollments or at 35 days BEC, we partitioned them out based on LDT thickness to have low muscle cows, which are an LDT of 4.37 centimeters or less, or they're 21, or high muscle cows, which had an LDT greater than 4.49 centimeters, and there are 20 of them. There was a similar representation of experiment number between these 2 groups. An analysis followed up using the mixed model of SAS version 9.4 And in the model, we included the fixed effects of group, day relative to calving, and their interactions. This also included the random effect of cow nested within group in the model, as well as including the covariates of treatment, lactation number being 2 or 3 plus lactations, as well as experiment number, and treatment in this case is relating to the circadian disruption studies to account for any variation that may be occurring through any of these covariates. And finally, statistical differences were determined at the p less than 0.05 level. So moving now into our results, we have our day relative to calving here on the x-axis, as well as on the y-axis, we have our LDT thickness, our LDT, or longitudinal dorsi thickness, from 0 to 6 centimeters. Differences in uppercase letters indicate differences in time points for high muscle cows, whereas differences in lowercase letters indicate differences for low muscle cows. Those uppercase letters marked by an asterisk indicate differences between the groups at that specific time point in LDT. And our observations here show that LM cows gain LDT from 35 to 21 days BEC, whereas no difference for HM cows throughout the length of the late gestation period. LM cows begin mobilizing tissue from LDT earlier, between 7 days BEC and calving, whereas HM cows start mobilizing LDT from 0 to 10 days in milk. And throughout the entire study, HM cows mobilized more tissue through 60 days in milk and still retained greater muscle reserves at this time point compared to LM cows. Moving in from ultrasounds and looking at markers of muscle mobilization in the postpartum period, both groups had similar creatinine concentrations at approximately 3,300 nanograms per milliliter per group. But when moving from markers of total muscle mass into the amount of muscle mobilizing 3-methylhistidine, HM cows had greater 3-methylhistidine at 530 versus approximately 440 nanograms per milliliter between HM and LM cows. And then when we incorporated the ratio by looking at amount of muscle mobilized based on muscle reserves, HM cows retained greater mobilization at 0.164 versus 0.131, showing they're mobilizing more of their tissue based on reserves. The other metabolites of glucose and NEFA, as well as the hormone of insulin, are also included here for reference during the postpartum time points. However, there were no difference in any of these markers and are left here for reference. Moving from muscle now into adipose tissue reserves and having the same outlay on our figure here as when we looked at LDT. This time it's for back fat thickness, or BFT. And one observation is that from 35 to 21 days BEC, our HM cows show a significant increase in BFT, having a subsequent greater amount of back fat at 21 days BEC. The HM cows mobilized more fat throughout the study, but onward from 7 days BEC through 60 days in milk, there was no difference in BFT between our two groups and did not show as many dramatic changes as were present for LDT in this study. And if we remove the effective group and look simply at how much tissue our cows mobilizing, we see that tissue reserves affect tissue mobilization, whereby on the x-axis here, we look at LDT at 21 days before expected calving, which was the absolute maximum LDT observed in our study. And on the y-axis, we look at LDT change from this absolute maximum to the initial minimum at 30 days in milk. And we see that those animals that had greater LDT at this max also mobilized more tissue throughout these time points, as well as those animals that had lesser LDT at enrollment mobilized less tissue in a moderate correlation with an R-squared of 0.37. Between muscle and on to adipose, we see a similar story here with a similar outlay, whereas those animals with greater BFT at this time point also mobilized more BFT through these two time points, being the absolute maximum and the initial minimum. whereas those animals with less reserves available mobilized less of those throughout that time period, with a very strong correlation present here, being able to fit the data with an R-squared of 0.87. Now on to production metrics, and looking at milk production and calf birth weight. HM cows gave birth to larger calves at 45 versus approximately 42 kilograms, and the covariate of calf sex was included in the model to account for differences in birth weight between bulls and heifers. Additionally, for milk yield, HM cows had less milk yield compared to LM cows at 39 versus approximately 41.5 kilograms per day through 60 days of milk. And the other observation here is that HM cows had a trend to have greater fat percentage compared to LM cows at 4.33 versus 4.05, while there was no difference observed for protein percentage between groups as we originally hypothesized, as well as no difference in lactose percentage or MUNs between our two groups. So in bringing everything together, we saw that our HM cows with greater LDT at enrollment mobilized more muscle as demonstrated via both ultrasounds and metabolites throughout the postpartum period for metabolites. These HM cows also gave birth to larger calves when accounting for calf sex, along with lower milk production, and suggests that these tissue reserves may have impacted nutrient partitioning between these two groups here and what impact that may have. And lastly, can we think about applications of this and looking at to feed cows in late lactation to optimize both their muscle and adipose reserves to best prepare them for that late gestational period and onto that subsequent lactation so that they can maximize both animal health, animal milk production, and therefore on-farm profitability. And with that, I'd like to thank you for paying attention to my presentation today, and I look forward to answer whatever questions you may have. Thank you.